Our lungs are a rather complex and very important part of the incredible human body. When we imagine respiration, sometimes we think of our breath, and while that is respiration, there's more to it than we may think. First off, how do your lungs work? To understand the lungs, we should look at the respiratory system in its entirety. The airways are pretty much oxygen and carbon dioxide highways. They carry oxygen-rich air into your lungs and potentially toxic carbon dioxide-rich air out of your system. The airways are your nose and nasal cavities, your mouth, the larynx or voice box, the trachea or windpipe, and the bronchi and bronchioles. The air you are currently breathing first enters the body through the mouth or nose, which naturally wets and warms the air. Cold, dry air is bad for your lungs and can irritate it. Next, the air passes the epiglottis, a thin flap of tissue that rests above the larynx and trachea and stops food and drink from landing in your lungs but allows air to pass through. Whenever you swallow, this covers the trachea but remains open all other times. The air heads through the voice box and down the trachea, finally entering the lungs. Now, we can talk about the lungs themselves. First, just the anatomy of the lungs themselves. Your lungs are split into 5 lobes. Your right lung contains 3, a superior, middle, and inferior lobe. As you probably already guessed, the superior is on top, the middle is in the middle, and the inferior is on the bottom. Your left lung contains 2 lobes, a superior and inferior lobe. If one or more of the lobes is diseased in either your right lung or your left lung, it can be removed and you can go on about your daily business without breathing problems. Just a quick fact, your left lung is a teeny bit thinner to save room for your heart, whereas your right is shorter but wider to accommodate for the liver. Plus, your lungs actually overdo it. They can hold way more than we need them to. Even at maximum exercise intensity, only 70% of your lung capacity is used. Maybe our caveman ancestors needed the full lung capacity for hunting and running. The trachea splits into 2 main bronchi, one for each lung. These bronchi enter the lungs, where they split into thousands of smaller tubes called bronchioles. At the end of each of these tiny tubes are bunches of even tinier air sacs called alveoli. They themselves are basically wrapped in capillaries or very thin blood vessels. In the blood is a very special protein called hemoglobin. Hemoglobin is responsible for the transportation of oxygen and carbon dioxide throughout the body. Right now, in the fraction of a second when it sits there waiting patiently, it is chock full of carbon dioxide. Then, as the alveoli fill up with oxygen, the magic happens. Due to the basic process of diffusion, just bear with me, the oxygen wants to move where there is no oxygen, and the carbon dioxide wants to move where there isn't any. So the O2 and the CO2 switch spots, the carbon dioxide is breathed out, and then we begin cellular respiration. Cellular respiration is another video in and of itself. Anyway, we should discuss how we breathe, not how the body uses oxygen, but the specific order of muscles expanding and contracting that is required for the lungs to fully expand. First, there's the diaphragm, a dome-shaped muscle that's right below your lungs. When you want to breathe in, the diaphragm contracts and moves downward. This increases the space in your chest cavity, which your lungs expand to fill. Since the lungs have expanded, air rushes in to fill the new space. When you breathe out, the diaphragm relaxes and moves up, essentially squishing the carbon dioxide out of your lungs. Then, there are the intercostal muscles. They're in between your ribs, and they come in 3 different quote-unquote layers: external, internal, and innermost intercostal muscles. The external muscles are responsible for inhalation. They raise the ribs and expand the chest cavity. The internal and innermost muscles exhale. They push on the lungs and decrease the amount of space in the chest cavity. Breathing doesn't use any energy unless you have a lung disease or are exercising. The abdominal muscles help to breathe out during said physical activity. They contract and push up on your diaphragm, causing you to breathe out much faster than usual so you can get more oxygen back in sooner. When these muscles don't work well, or when lung disease impairs your breathing, your neck and collarbone muscles pitch in to help you breathe in. Since I'm using the free version of Powtoon, my videos can only be 5 minutes long, and since this video requires much more time than 5 minutes, I'm gonna have to split this video in 2 parts. See you next time. Bye.